Hi everyone. We're going to run through a bit of review here. We're going to have quite a few assignments that focus a little bit on what I hope is review. Part of what I'm going to use these for is just to point out some things that you need to know. So for example, I'm about to go through some geometry formulas that you'll need to memorize. We'll add to that list in a little bit, and we'll also have some geometry formulas that I want you to be aware of, but you don't necessarily have to memorize them. So for now, you should memorize the 2D geometry formulas, the basic shapes that I have right here. You will have some of this just to play around with in your homework, but also you could just make flashcards if you don't have these down. This is not something that you want to have to be going and looking up every time. They're going to come up over and over throughout this course and other courses. So for starters, you should know square. To get the area of square, in general, to get areas, we're trying to multiply length by width in some form. So we need to multiply two lengths together. In this case, the length and the width are both s. So we need s times s, which is s squared. And perimeter in general, we're just adding up the outside lengths. Easy as long as they're straight lines. In this case, there will be 4 of those. 4 sides, each one is s long, so the perimeter is 4s. For a rectangle, same idea, but the two dimensions are not the same, so we can't just multiply w or l by themselves. We have to multiply them by each other. So multiply the length by the width. And then to get perimeter, again, it's not quite as simple, but we can see that there are 2 lengths and 2 widths. So we're going to take 2 times the length plus 2 times the width to get our perimeter. For triangle, it really is a similar idea. So we're starting with that length times width idea. It's base times height here. But what you get if you do that is this rectangle right here. If you multiply that base by the height of the triangle, you get the area of that rectangle. And really, this is equal to this triangle here, and this is equal to this triangle here. So we've really only filled in half the rectangle, so it's half of base times height. And then perimeter, there's nothing special going on here. We don't get to assume that any of the sides are necessarily equal. Could be if you have certain special triangles, but otherwise just add the 3 up. Okay, the one that tends to be just a little bit tricky is circle. So if we do the area of a circle, it's going to be pi r squared. It's just a more complicated shape. So we get this pi in the mix. And also there's some similarities between the two formulas. We also call perimeter something fancy. For circles, we call it circumference, and circumference is 2 pi r. Notice, though, we've got the length times length happening here. We've got r times r, so that would give us area, whereas a plain old r, that's just length. That would not give us area. So you have to see 2 lengths multiplied together to get an area. Circumference, if you like it better, hold on, I'm writing it wrong. You could also remember as pi times the diameter. So either way, but I do notice that sometimes people make mistakes with where the 2 goes. So if you tend to be one of those people that accidentally sticks the 2 on your area formula, maybe a better way to remember it would be pi r squared and pi d. So there's just never a 2 in the mix. Okay, let's work on an example. To make this a little more interesting, I'm going to do a composite shape, and you'll have some of those in your homework as well. The big thing with composite shapes is just correctly taking them apart into simpler shapes that we know the formulas for. So when I look at this, I'm seeing up top a quarter of a circle, and I'm also seeing 2 triangles and a rectangle down here. And I think it is safe to assume that those triangles are identical. So they both have that hypotenuse of 3.5 centimeters. It looks like that 4 centimeters is centered in the middle. So we do know that this total distance is 9 centimeters. If we subtract off that 4 in the middle, that leaves us with 5 centimeters to cover the tops of the 2 triangles. So if we're sticking with that assumption that they really are the same size, then those would each have to be 2.5 centimeters. And then we know that the height is 2 centimeters. Okay, so let's start with the circle. So if we want to find the area of the circle, circle, I'm just going to use a little subscript to keep track of what's what. Area of a circle is pi times the radius squared, but this is not an entire circle. This is only a quarter of a circle. So I'm going to put a 1/4 in there, which means I have 1/4 pi times 16, which is just 4 pi. And that's going to be square centimeters. Next, let's do the perimeter of the circle. Normally we would call that circumference, but I don't really want to see sub c, so I'm going to just keep it as perimeter, and it does mean the same thing. So again, this is only a quarter of the circle, so I'm going to put a 1/4 out in front of my formula, and then we need 2 pi times the radius. So this time we're actually going to get to cancel a 4 out of that, and we're going to be left with circumference of that little section is 2 pi centimeters. So this is a 2 pi centimeters. This is a 4 pi centimeters squared. Okay, let's work on triangles next. So the area of one of those triangles is 1/2 base times height. So I'm going to use 2.5 as my base and 2 as my height. Note that you could reverse those, it wouldn't matter. You could think of this right here as your base and this is your height, but we don't have enough information to think of 3.5 as the base because your height has to always be perpendicular to that, and we don't actually know that height. So if we knew it, we could use that as well, but we don't know it. So we want to use either the 2.5 or the 2 as our base. Okay, so looks like we get to cancel a 2 out again, and we're getting 2.5 as the area. So this is 2.5 centimeters squared. For the perimeter of the triangle, we actually don't need to use all of it because not all of those sides are actually on the outside of this shape. So I will just say, if you wanted the perimeter of that triangle, you would just add up 2 plus 2.5 plus 3.5. But for our purposes, I'm just going to save that one up for a minute. I've got that 2.5 labeled on top. So let's see if we can figure out everything that we need from there. I think the last shape that I need to deal with, let's get another color here, is the rectangle, and it should be easy. It's got a base of 4 and a height of 2. So the area of the rectangle is 4 times 2, which is 8 square centimeters. And then once again for the rectangle, we don't need its entire perimeter. So if we did, we would add 4 plus 2 plus 4 plus 2, we'd have our perimeter. But let's see if we can pick apart what pieces we actually need when we get there. So it looks like area is actually going to be the easiest here. So this is going to be our total area. We need the 4 pi square centimeters, and then we need the 2.5 for the triangle, but we actually have 2 of those. And we need the 8 centimeters squared for the rectangle. So here we're going to get 5. So it looks like we have 4 pi plus 13 square centimeters. And in general, leaving that answer exact with the pi in it is fantastic. If you're asked for a decimal, go for it. Otherwise, I would rather just see that 4 pi plus 13. Okay, so this is our area. We're going to have to be a little bit more careful about perimeter, but it's not maybe quite as tricky as it looks for a second. What's interesting with this, I think we have just about everything labeled except for this length right here, which looks like you might have to do some fancy figuring with the 2.5 that I just erased, but I actually think we get it for free from this circle because we know that the radius of the circle is 4, which means we know that that chunk right there is also 4. And if we again use this total distance of 9 centimeters, that means over here we have to have 9 minus 4 or 5 centimeters. So for the perimeter, we'll start there. We'll start with the 5 centimeters, and then we have the 3.5 for the triangle. Let's go ahead and just double that while we're at it. And we have the 4 for the base of the rectangle, and we have a 2 pi to get around the arc of that circle. And then I think maybe kind of easy to forget, but last but not least, is that 4 centimeters to get us back where we started. Which again, if you add up everything that doesn't involve a pi, I think I'm seeing 20 there. So I'm seeing 20 plus 2 pi. Those were all in centimeters. This is a length, not an area, so that should just be centimeters. And unless my open math is telling you otherwise, 20 plus 2 pi is a great answer. If you're ever running into homework problems that don't specify how they want the answer given and it seems to disagree with what I talk about, let me know and I can fix that usually fairly quickly. I do try and check that, but I've built a lot of new questions lately, so there might be some where I haven't caught that they're not quite set correctly. Okay, so that's finding perimeter and area of composite shapes. You'll have some different shapes, but hopefully nothing that gives you too much trouble. Let me know if you get stuck on anything. Thanks for watching.